Welcome everyone. So as Alex has said, this morning what we're going to look at is data organization in spreadsheets, and then this afternoon we'll go on to open refine. And there's little bits of overlap between the two, but basically the data organization in spreadsheets, what we're really looking at is try and give you an understanding of what good data looks like. If you remember at the end of that tree, you're going to do data analysis and visualization and what have you. Well, the products that you use like R to do that kind of like the data being in a nicely arranged and organized fashion, not haphazard. Okay, so what we're going to look at this morning in spreadsheets is how you would put data into a spreadsheet and some of the potential pitfalls of what you may find. So getting started, just on the setup side, if we just click on the data organization spreadsheets, it should bring up this page here. Quick show of hands if everyone, just to make sure everyone does have this, or if everyone doesn't have that, please do show. But hopefully everyone's here. And really, this is just, if you go down here and click on the setup on here, it will take you to this page, which is going to explain what the data set is about. This is the data that we're going to use. That's really just for background reading. It's about rodents, sampled over 20 odd years, I think, in total. We're just going to look at little parts of this data. And as such, we've got some specially prepared data sets for you, which if you come down here after this, the pink bit, if you download the messy survey data, XLS, and perhaps these are the three as well, these should download automatically or give you an option to download them, and you can save the file. Typically, they're going to be saved and download. You put them wherever you like, as long as you can find them subsequently. Okay. So, has everyone managed to download all of those? I can just see. Show of hands, please. Everyone got all the data sets downloaded and available to find. Show of hands, as in the Zoom tick boxes and check boxes. That's okay.
Sorry, I can't find that page there. I'm having to flick between screens, so I missed it.
Right. I'll take you back to the beginning. Okay, so this is one. You've got this page.
I have that, yeah, and then I click
down here. The first item, yep. Data organization spreadsheets, and then the setup.
Oh, perfect. Thank you.
Yeah. And then the data sets are just listed down there. So just check if everyone's managed to find that. I've got some little icons, little cloudy icons with red dots in. I've no idea what that means. Alex, anyone help me? What is a little cloud dot?
Oh, it's recording. It's because it's recording.
Oh, I see. Okay.
And I've just pasted the link in the chat to the messy data file that you will be working with.
Okay. I haven't got all of the hands, but I haven't got any crosses there, so I'm assuming we're okay at this point. Oh, I have got one cross. Helen, you're having difficulty? You're still showing a cross there, Helen.
Yeah, sorry, I have it. I'm just trying to flick.
Okay, if you've got it.
This is.
Yes, I know.
Is that
like with spreadsheets and Zoom, it's tricky stuff, I know. Okay, so we've downloaded all the files. Just as long as you can find them and load them into Excel or whatever later on. So while we've got the little Zoom bit up, let's ask the next question, just out of curiosity. How many of you are using Windows? So green tick for Windows users, please. Okay, the majority are Windows. Currently showing 2 crosses for Maria rather, and ML. Are you? Oh, another one for Natalie. Are you using Macs?
Yes.
Yes. No one using Macs. Is any? Yeah. Okay. If we can clear the ticks, is anyone using Linux? No. Okay. So majority Windows, about 3 Macs. That's fine. And all the Mac users all using Excel on Mac? Yes, yes, yes. Okay, good. That hopefully that'll simplify things a bit because we will have to keep switching over things. Excellent. Okay, thank you for that. We've all got the files downloaded. We've all got the software installed. Time to move on. So the first episode we're going to look at, if you go to the top, you can find the episode's introduction. And this is basically just going to explain what it is we are going to do and what it is we're not going to do. Because there's a lot of things that Excel will do which really tread on the toes of the other things, and the other tools are far better at it. So we're just going to use Excel in the way it's very commonly used for data capture and data entry.
Peter, could you just make the font a little bit bigger, if possible? Yeah, but...
Oops, let me just move you out of the way. Oh. Is that okay?
That's great, yeah.
Righty-ho. So what we are going to do and what we aren't going to do. So let's have a little look at, well, what do you use data spreadsheets for? Data entry, yes, but you can use it for other things. They've got graphical interfaces these days. Excel's graphics get better and better, but that's not necessarily a good excuse to use them. Little things, data organization, the foundation of your research relies on data analysis. The reason we want to use data organization and do it properly is it helps limit the amount of data wrangling and data cleaning we subsequently have to do. If you put your data in right first time, that's great. You can move straight through, well, check that it's clean, and then you can move on to the later stages. So what we're going to do, we're going to implement the best practices, identify and address common formatting mistakes. This is really the key part of this, addressing the formatting mistakes. And again, if you can avoid them at the outset, that's great, but you have to bear in mind that a lot of the data that you might be required to use in your research may have come from other sources which you can't control, and you've got to take the data as it is. So that is the data that is more likely to suffer from the mistakes, and you're going to have to be able to clean up. This one item here, understanding the process for handling dates in spreadsheets. You'll find that dates are mentioned in this lesson this morning. We'll go back to dates a bit this afternoon in Open Refine, and I'm sure they'll get mentioned tomorrow when you do R. Handling dates in any software can be quite problematic. So we have to take very careful attention, pay attention to it. Basic quality control features and data manipulation practices. Well, that's just a restatement of other things. But what you might cover in there under quality control is validating data on input. And we'll look at that later on. Effectively export data from spreadsheet programs. The problem, or one of the problems with spreadsheet programs, is that they tend to use proprietary formats. So in Excel, we've got, well, if we go back to pre-2007, we've got XLS format. Since then, we've got XLSX format. And the other software tools, LibreOffice, have their own ODT, I don't know, some other format, which is proprietary to them. So the problem we have is that a lot of these are very common programs and lots of people can deal with them. What we're really looking for is a way of exporting the data so that pretty well everyone, every software product on the planet would be able to read it. And we'll see later that's a format called CSV. And all of the spreadsheet programs will be able to use their proprietary format when you're using the product. But if you want to export the data, it will always allow you to export it in CSV format. And that's a good thing, and that's what we're going to make use of later Know the overall good data practices. Well, we've got whole sections on that. And again, I'd have to say that a lot of them are common sense, and you probably wouldn't fall into the traps if you were left to your own devices. But there's other ones which are a bit more subtle, and it's really you've got to sort of think how software might think, as opposed to think, well, isn't that obvious to another human being? You know, many times it is obvious to another human being, but not so obvious to a computer. So we have to be a little bit wary of that. Just on what the spreadsheet programs we've got, well, I think we're all on Excel, so that's okay. But they can be used for a variety of things. Data entry, yes. Organizing the data, yes. Subsetting and sorting the data, statistics and plotting. Well, the first two, yes, we're definitely interested in doing them. These last three are possibly better left to other programs. A bit of it, the subsetting and sorting and perhaps cleaning the data, we're looking to Open Refine. And the statistics and plotting, although you can do them in Excel, they're better left to the likes of R and Python. One of the downsides of spreadsheet programs is that they are all typically drag and drop, point and click. And the problem with this is that there's no real audit trail of what you did. There's no record kept of what you're doing. Okay, so you're using a spreadsheet day in, day out, and then it gets to a state where you think, well, how did I get that set of cells there? Oh, I think I dragged them from somewhere up here, one of these options, and but which one was it? So it's not very good for keeping track of what you've done. Whereas the programming languages and Open Refine as well will keep track of what you've done. And that's very important in research. Yeah. The other slightly associated with that is the fact that introduction of errors. Not error in the data, but errors that you have introduced in the creation of the spreadsheet. There's a comment here. 20% of genetic papers contain errors due to Excel converting gene names to calendar dates. Now, on the face of it, you think, well, surely someone would have spotted that. But then just think, we have very recently had the case where someone didn't realize that the old Excel format only took 65,000 rows, and that caused a problem with the COVID data. And there are lots of other well-established and well-known problems. I've certainly read in the past that up to a third of Excel spreadsheets, many of which are used for high-powered financial data in business, up to a third of them contain errors. Okay, and just to try and show you that, somewhere I've got on this link here, 12 of the biggest spreadsheet fails in history. I think this is a year old, so there might be some more to add to this. And it just gives you a list of the various things, examples of what went wrong. To my mind, the most famous one that I know of is this one, number 4, the Reinhardt-Roghoff. Harvard professors did this, and they were using their data in a spreadsheet. This is an example of their little data, and they were trying to do some summation, and they wanted to group all of the countries. And what did they do? They dragged down to there and then stopped. So there's a couple of countries which got missed out. And the sum of that, or the average, I don't know what it was then subsequently used in further calculations in the spreadsheet. So you can imagine that it's compounded the mistake and everything went wrong. And it took nearly a year before anyone spotted that. It was only spotted by another research student wanting to reproduce the results. Okay, there's no record of that step in Excel. Yeah, it's very easy to do, just accidentally miss something out. I mean, it looks less obvious there when you see it on that diagram, but on that picture, but it is very easy to do. And it's very easy to do in Excel, but that kind of mistake is actually quite hard to do in a programming language like R, which you'll probably find out tomorrow. Yes. So some things we entrust to spreadsheets, like the data collection and the basic organization. When it comes to doing the actual calculations, I mean, despite the fact that it's a spreadsheet, for research, you tend not to do your calculations in the spreadsheet. The other one I wanted to show you is this one here, MI5. Even spies make mistakes. In 2010, the British Intelligence Agency bugged more than 1,000 wrong phones. A formatting error on a spreadsheet caused the agency to apply for data on all telephone numbers ending in 000 instead of the actual 3 digits. Now, again, you may think that's a bit of a silly mistake to make, but there is a very modern 2020 counterpart to that, and that is in using Twitter IDs. Each tweet, if you haven't used Twitter before, each tweet has its own little ID. Let me just, the Twitter ID is shown up as a long number. And if you open a file, and I've got here Twitter broken CSV, so I'm just going to find the original file on my desktop, Twitter, here's Twitter CSV, all right? This is, if I open this and show you the actual text of what's in there, this is just a little text editor, and you can see here, this is a tweet ID, a very long number. And it's such a long number that some software can't cope with it very well, okay? So when you get, if you're dealing tweets, you get this Twitter ID as a string, which is what this is. See up here, it says ID string, but they are in fact numbers essentially, or the all digits, okay? Now, if I take that file and load it up into Excel, which it will do automatically for me, you can see what Excel does to those strings. It's saying, oh no, they're numbers, they're numbers. And it will treat them automatically as in this format. You can change the format and say, I want this as just as a number with no decimal places. And you see what Excel has done. It's rounded everything up. It's done exactly what happened to those telephone numbers. Okay, so one of the things you have to be very careful about when you're dealing with data and putting them into Excel spreadsheets. If I was now to save this file, I end up with the broken version, and they would in fact be copied back out as those wrong numbers. Yeah. Moral of the story, be very careful how you're dealing with data. Even numbers in spreadsheets can cause you problems. And there's lots of other examples there as well. Problems with spreadsheets. Yes, I think we've covered that. I've mentioned the drag and drop issue and the fact that there's no audit trail. And these are essentially the 5 sections that we're going to go through in a little bit more detail. Formatting data, the errors, dates gets its own little section. Quality assurance, that's really about input and then exporting the data. If we move on to the next section, little arrow at the bottom here. And what we're going to look at in formatting the data. How do we format data in spreadsheets for effective data use? Describe best practices, apply best practices. So the little arrow, pins here are little bits of advice. And at this point, I would say that yes, we're going to show you what is best practice, but you have to bear in mind that specific cases may require slight alteration to that. The first thing we want to discuss is I've pointed out that in Excel, one of the problems with Excel is it's very drag and drop and point and click, and there's no audit trail. So from your point of view, even when you're doing the preliminary stuff like organizing the data, you need to keep a track of what you're doing. Okay, so the suggestion is here is that you've got your spreadsheet, and then in another file called perhaps README, a README file in the same folder as the spreadsheet, you keep a little log of things that you've done and when you've done it. Okay. And just simple steps of this is what I did. So if this spreadsheet goes to someone else, you send them the README file as well, and they can see how you did it. The other thing, which I'm not sure if it's mentioned here, but somewhere else, is when you're cleaning your data or organizing it or changing the organization of it, you always work on a copy of the original data. You never, ever, ever alter the original data. Okay. And if you want to, if this goes through many iterations, one of the things you might want to consider using is some kind of version controlling your data. And there's a reference here to the Git version control system, for which there is a software carpentry lesson. And lots of other lots of other training available on Git. It can be quite complicated, but for just simple keeping track of versions of or iterations of your spreadsheets, it can be quite useful. So let's look at a spreadsheet or spreadsheet data and consider some things that we might want it to look like. So cardinal rule is keep it tidy. Well, the other cardinal rule I've already mentioned is never mess with your original data. But yes, keep it tidy. So how are we going to do that? We're going to put all your variables in columns. Each column, one variable. Things you're measuring like the weight or the temperature or whatever else. Each observation in its own row. Do not combine multiple pieces of information in one cell because that causes confusion. Why not just use another column? You're not short of columns. Leave the raw data raw, do not change it, we've done that one. Export the clean data to a text-based format like CSV, comma separated values. Is everyone familiar with CSV format? Yeah, nods of heads I see. Okay, that's good. That ensures that everyone can use the data. I've already mentioned that. So let's have a look at some of the data from our survey sample here of the small animals in a desert ecosystem. This is the data that we're going to be looking at. So the idea is that this data has been collected over, I think, many years, in fact. So as you can imagine, different people will have gone out and collected the data, and they all had their own little way of putting it into a spreadsheet. So one of them came back and recorded the data like this. So date collected, yep, dates. Plots, I think if you read the description of the data set, it tells you that there's up to 24 plots. So what they're saying is that on this date, in that plot, I found species of whatever DM represents, and it was a male, and it had a weight of 40 something or others. Okay. So the problem with that is the species sex. It's trying to record 2 bits of information in one column. Yes. It's probably highly unlikely. Well, you may want to use them both together in some kind of analysis, but you'd probably be easier to deal with them if they're in separate columns. So all this second table is a slightly tidier version of that, where we've separated out the species and the sex. There are other little things about this which would have to be resolved, and possibly we would already know. For example, what the weight is that kilograms or grams? And then if you look at these dates, you can probably work out what format or what kind of format it is. So 1st of the 9th, 78, is that the 1st of September or the 9th of January? Well, it could be any, depending on where you live in the world. But if you come down to here, 3/13/78, that can't be the 3rd of the 13th month. So it has to be the 13th day of the 3rd month. So that tells you the format of the dates. It doesn't tell the computer that. It doesn't tell a spreadsheet program that. It will make its own assumptions. And as we'll see later, it can easily get that wrong. Okay, and we'll cover dates in far more detail later on. So the point here, columns for variables and rows for observations, and this little rule of thumb is quite good. Columns equals variables, rows equals observations, the cell equals the data values. In fairness, I think a lot of that is common sense, and if you were starting your own spreadsheet from scratch, you'd probably do that automatically. But as I say, the real issue is not the data that you're going to record, it's the data that you inherit from someone else. Okay. So now we're going to look at some fixing of the mistakes. We've all got our messy survey data, and we're going to open this up in a minute. If we go to Excel, I've actually already got mine opened up. Just going to make that bigger. Do I need to increase the font on that a little bit? So hopefully we've all got this loaded into our version of Excel. And it should, hopefully, if you go to the 2013 tab, it looks like this. Dates. We're just going to start off looking at these 2013, 2014 tabs. I'm just going to find my place on the other screen. Okay, I'm just swap back so we can see what I'm talking about. Okay, so what we're going to do is a little exercise. We've got, if you've got the other data sets downloaded, the surveys and the combined surveys, you can have a little look at them if you want to. But basically, what we want to do with this little exercise is we'll take the messy version, which hopefully you've all got loaded up. Look at the tabs for 2013, 2014. Now, the idea is these represent the years in which that data was collected, and identify what is wrong with the data in these two tabs. And what we'd like to do is to make a list of things which you see are wrong, and hopefully there'll be a section in the Etherpad where that can be posted. We've got that somewhere. Data organization, so yes, we'll put it somewhere starting perhaps line 60. All I want you to do is to have a look at that spreadsheet, decide what all the things you think are wrong, things that you wouldn't do, and list them in here. It doesn't matter if we get repeats. Let's just spend a few minutes on that and see how many we can pick up. Okay, so let me just go back to the spreadsheet. So we're looking at 2014, 2013. Just think about it. Try and empathize with your little computer that's going to do your analysis for you. What would it like to see in terms of data formatting? Okay, so have a look at those two tabs. Write your what you think might be wrong with it in the Etherpad, and we'll have about 5 minutes thinking about that. Okay, off you go. Any questions, please do use the chat so we can see if there's confusion or anything like that. Just to point out in case you hadn't realised that there's a plot 4 on the end of the 2014 tab. If you're just looking at the first screen, it may not have been too obvious to you that there was a plot 4. Whereas on 2013, you can see them all on one screen. Oh, time up. Okay, everyone had a good bit of fun with that. Let's have a look at the spreadsheet and see what we have got. Quite a collection, as you might expect. I'm just going to run through these quickly because in the next section we're going to go through them in more detail, if you like. So what people have written, grams in the cells. Yes, because that's equivalent of having 2 bits of information in the same column, essentially in the same column. Multiple tables in one sheet, yes, definitely. Definitely a problem because I haven't actually said it, but yes, when you recording data in a spreadsheet, ideally you only want one worksheet in the workbook and only one table in that worksheet, because that's makes it easier when you're exporting it into CSV for a programming language. Empty cells between data. I'm taking that as sort of the equivalent of multiple tables in one sheet, because we've only got empty cupboard because we've got multiple tables, I think. I don't think there's any where there's actually within the table frame there's any empty columns. Whereas here it's an empty column, but here the real problem is not this empty column. The real problem is you've got 2 tables. Yeah. Grams in cell instead of a variable. Again, if that's in the same cell, that's a problem. If it is a column which is telling you how the weight was, or what the weight is in, the units of the weight, then that might be acceptable. Yeah. Description and date recording method. Yes, we'll cover dates a lot later on, but there are lots of various ways of recording dates between here and between here, and I think on the other sheet as well we have not so much variation, but yes. Variables not written out properly, weight rather than weight. Well, there's nothing wrong with using WGT for weight, providing somewhere in the notes it explains that WGT means weight. Yeah, we'll have a little section on metadata later on where we'll explain that. We'll cover that. Underscore used in value name rather than comma. That's an interesting one. Where's that one? Can someone indicate to me where that is?
I'll be on plot 4.
A big one?
On plot 4 on 2014.
Plot 4, you mean here?
I think so. I didn't write it.
Okay. Well, what I would say is using underscores, certainly in column names, is probably a good practice. Certainly don't use a space, as we'll come to later on. And again, the real problem here is it's got 2 bits of information in the one column. So if it was split into columns, as we saw in the example on the notes, the underscore wouldn't come into play because you wouldn't need one. It'd be separated out. I think in the, I'll go back to the notes. I'll find the notes. See, it's actually the same way it's done there. You wouldn't, well, that's got hyphen there, but it's the same difference. The problem here is the fact that you've got 2 of them in the one column. If you were really going to do that and you change that to commas, that wouldn't help things. That would probably just make things worse in terms of the organization. Back to lack of data in some columns. Well, commonly referred to as missing data. Now, missing data is a fact of life. Again, certainly in stuff that you inherit, possibly in what you're recording yourself. The important thing about missing data is how you represent it as being missing. And again, there may be various reasons why it's missing, which you may wish to distinguish. But again, as long as you leaving something empty, as long as it is explained why it's empty, that's not such a great problem. Something that you can deal with. Data collection, dates. Yes, the overall format is different between the 2 years. And if you wanted to combine these, doing something over the years, then that's going to be a real massive headache for you trying to sort that out. I think this is telling you about different date formats, which we'll come back to. Some boxes are highlighted grey. What does that mean? I think it does actually tell you at some point what they are. Grey cell means so that information is in there, but the real question is, it's no good having it in that box because it's trying to tell me something, but it's not something which will be successfully exported in a CSV. So ideally, if you've got a comment, you need to have a column called comments and put it in there. Or in this case, not calibrated correctly, and I think in the other one, there's some way it's actually written into the actual cell. Same thing. So in fact, you might be better off having a column saying calibrated or not calibrated and having a boolean or something like that. Okay, lots of ways of doing it, but certainly this one fails because it's effectively trying to tell me 2 things in one cell. And the other one fails for a similar reason, that it's really 2 things in one cell, and then this is totally detached from the table. Missing values, data with no yes, that's missing values, formats, cells, yes, combined, we mentioned that one, empty records. Plot 13, 5 and 6, 2014, 5 and 6. 2014. Oh, Marie. Plot 3, 5 and 6. Plot 3.
It was the date 5.
Yeah, missing data. Yes. Okay. So you see, on some of them, perhaps they couldn't weigh them. I don't know, but the fact that they had the species, you'd want to explain why they were there, not necessarily in the data table, but somewhere in the metadata you need to explain that. Comments in boxes we've covered. More than one data set on a tab. Yes. 1978 data and 2014 data. Yeah, we'll come back to that when we look at the dates. So there's quite a variety of things there that we've picked up. What we'll do now is go back to the notes. We'll find them again. And then in the next section, we're just going to look at some of these errors and consider what needs to be avoided and what we might do with them. The bullet points up here, just a list of them, and we're going to see them one by one as we go through. This little exercise, using the same messy data where you attempt to clean the data, have a look at each of the spreadsheet errors described above and fix your spreadsheet. Won't necessarily go do that. I'll just go through them and we'll see what they are because we've got a cleaned up spreadsheet later on. But I think some of them, as we go through them, you have a little think to yourself, would I have done that or would I got it right? Because some of them are, I think, are pretty obvious and some of them are a bit more subtle and you'd have to think of it from the computer's point of view. So the first one we've got is this problem of using multiple tables. Don't do it. One table per worksheet, and preferably one worksheet per workbook. Okay. If you're not going to do any kind of analysis between the tables in the spreadsheet, there's absolutely no harm in having multiple files with only one table in each file. I think there's other little things wrong. In the example, the computer will see, it's really just explaining here why this is a problem to a computer, because computers do actually read rows at a time. So it's going to read that blank row, and then it's going to read this, and then it's going to read that, and so on. And it's almost impossible for us to keep track of this little section down here, all just looks like missing data, and so on and so forth. And really, the chances are you're probably going to want to have all of those 8 little tables as one table when you're doing the analysis. So there's very little, there's absolutely no point at all in recording them that way. Cool. Using multiple tabs, I've sort of suggested don't do it. The reason why multiple tabs is a problem is that when you export data in CSV, typically it will only export one tab at a time. It will export the tab you're currently pointing at, but then you've got the problem of renaming them, giving them names, and so on. It won't pick up the name from the tab. And again, because you're not, or highly unlikely, going to be using the spreadsheet to process the data, there's no harm in just using a single tab per workbook in a single file. More likely to add inconsistencies? Well, quite possibly. The problem with using multiple tabs is you're going to be tempted to try and link the data between the tabs. And again, that's information that will get lost when you try to export. Note on bigger data and column headers. Your spreadsheet get very long over the course of experiments. Well, providing this makes it harder to enter data if you cannot see that your headers at the top. Well, in fact, there are now ways of avoiding that little particular problem in an Excel spreadsheet, which I'll show you in a minute or two. And we know that Excel spreadsheets now go up to 1 million rows, and you can. I'm not sure how long it takes you to collect 1 million rows manually, but if you were collecting them manually, you could still arrange to putting the 900,000th entry in and still see the header tables, the table headers. So it says it's pointing you here to see the documentation how to freeze column headers. Well, that's a bit old now. The more modern way would be to use an Excel table, and that will do it automatically for you. Not filling in zeros. It might be that you're measuring something that is mostly zero. For example, the number of times a rabbit is observed. I don't know why picking rabbits, obviously not very common. Why bother writing in the number 0 in that column when it's mostly zeros? Well, the point is you've got to record what you see. If you didn't see any rabbits, you put 0 in it. If you put nothing in it, left it blank, that is missing data. That means I don't know if I saw any rabbits or they saw any rabbits when it was collected. Yes, the very, very sharp distinction between I saw no rabbits and I do not know if any rabbits were seen. And you have to make sure that the data reflects that distinction. So if you saw no rabbits, you put a 0 in. If you didn't look for any rabbits and you don't know if you saw any or not, then you would leave it blank. And then that becomes missing data. And as I say, we need ways of dealing with missing data. It's a 0 and a blank. I'll consider that. Problematic null value. So now we're talking about what happens if some data is missing for whatever reason. The data isn't there, and there's lots of ways of representing missing data. So, for example, and some of them depend on whether it's numeric data that's missing or text-based, perhaps categorical type data. Now, for example, okay, mixing 0, right? We just discovered mixing zeros and null values. Don't do it. If it's 0, you say it's 0, and if you don't know, it's a null value. You leave it empty as a null value. Null means missing, not there. I know nothing about this. Yeah. I don't even know if it was meant to be a number or a string or anything else. I know nothing. However, some software will give you the option of using certain values to represent null values or missing values. So this -999, I think -99 is also used. Some of the software packages like SPSS and Stata will commonly do that. And a lot of the published data, I'm thinking coming from things like the UK Data Service, when they publish data, they will quite often, because it's often SPSS based, they will use -99 or -999 to represent missing data in the data table. But having said that, they will also very clearly tell you in the description of the data, -999 means missing data. And that is the important point. And then it's up to you. Once you know that, it'll be up to you in your analysis or processing to take account of the fact that -999s are not real values. So don't try adding it to anything. That's what it's saying. So Daisy, my mistake. We'll talk about Open Refine this afternoon, so we'll go into more detail about missing data then. But what the key part of this is this little table, and this is going to suggest what you might use and what not to use if you have missing data. You do not know what it is. Okay, so possible options for the null values are 0. Well, the problem with that, can't tell it from a true 0. That's the example I've been using. Never ever use that as a null value. Blank is probably your best bet. If you don't know, just move on, miss it out, okay? Because most programming languages will interpret blanks as missing data, and it will then put its own interpretation onto it, which you will know because you're dealing with that language. The -999 and the +999, I've already mentioned. Some programming systems, some products use that. As long as you know what they are and you don't try and do an arithmetic on them, that's you can get away with it. To say avoid, but you'll find that potentially in lots of data that you inherit. The NA, N/A, these are all variations of the same thing, saying I don't know what it is. Now, in some languages like R, they will recognize that, so you might get away with using that. Don't use the N/A because it doesn't get recognized by anyone. And null here can cause problems with data. In fact, you would never actually write in null, NULL, because that's just a 4-character string, NULL. That's not what you intend it to be. Okay, SQL systems, by pretty much, I think, across the board, will, if it comes across missing data, it will display null written NULL. But that's just for your benefit. It hasn't got NULL written anywhere. Yeah. So you never actually write that in yourself. You may see it in a database, but you never actually write it in yourself. And similar, no data missing, pretty much you can avoid it. None is, in fact, a recognized word in Python, but again, you probably don't want to use these unless you've clearly indicated, I am using this to represent missing data, and then all your subsequent processing, you allow for the fact that those values are there. The other problem with a lot of these written character ones, you may not be able to put them into numeric fields. It's going to cause you problems. If you're expecting a number and you type in none, hopefully you should never do that. In fact, later on, we're going to find ways of stopping you doing that. And equally, I've never actually seen anyone try to use them for null data types. So basically, what we're left with is, if you don't know, leave it blank. Okay. Next little section, using formatting to convey information. We got this on our little list, and you can see here a little example here where we've got a little bit of color coding. Now that might stand out to someone reading it on the screen, you or I, but this is totally useless to a computer. Yeah. you're effectively trying to put 2 bits of information into that one cell. So as you'd see here, what we've got, this has been redone with a calibrated column saying yes, yes, yes. Missing data means I don't know, and a few no's as well. So the 157 and the 218 have been recoded as no, to say it's awesome calibrated. Making formatting, using formatting to make this spreadsheet look pretty. Again, I don't think this is an error that you're likely to do if you're doing your own data capture. You probably do it nice and neat little tables. But where you will come across this a lot is if you've inherited a spreadsheet which has been created as a report. So quite often, yes, there'll be color all over the place, no doubt. There might be multiple headings for columns, you know, monthly report, March 2020, sales region, whatever, all on multiple lines. And that doesn't really help you at all. You really want to know the date as a column. You want to know the sales region as a column. Yeah. So this can just take them out and making it look like a report may be good if it's going to be used as a report, but it's no use to you as a data file. So you have to reformat that to take that into account. Placing comments in units or units in cells. Well, we've covered that. The problem is you've got 2 bits of information in one cell. You need to split them out. It doesn't matter if it's a comment or the units. You'd split it out into a separate column. It says most analysis software cannot see Excel or LibreOffice comments. Well, the reality is if you've exported it as a CSV file, you'll just lose them anyway. Any color coding that we had is just going to get lost. If you have got more than one piece of information in a cell and I don't know, you separate it by commas or hyphens or whatever, all you're doing really is creating more problems for the analysis program because it will have to break that down into 2 separate bits of information. And that is potentially very much prone to error. So, and like I say, it's not really costing you anything to have an extra column in there. Problematic field names. Okay, we touched on this. I mentioned this slightly about how you name fields or how not to name fields. So the basic rule I always use is I tend to use underscores. If I've got a variable name which reasonably needs to be split into 2 words, I would use an underscore, but there are other ways of doing it. So what we've got here is a good example, max temperature, and it's trying to tell me it's in centigrade, and it's using underscores, okay? An alternative is no spaces and capitalizing the individual words. Notice that I've left off, there's no C on there for some reason. I don't know if that's an error or not, but keep it all, no spaces. The rule is don't put spaces in here. So this is the one to avoid. Not only has it got spaces in, excuse me, it's also got this special character for the % sign in. I would also avoid brackets as well. Okay, so that's a good one. That's a good alternative. If you go down the list, these all have very, hopefully, reasonably obvious ones. Statistic, underscores, single words. Don't try and run them together like that because it would just become unreadable. That's okay, that's okay. Oh, don't use a slash because that can cause confusion. Yes, yes. Again, a slash is a problem, not readable. Wait, fine. That's got a full stop there, I don't know if you can see that, but don't use any characters apart from numbers, letters, underscores, pretty much in your variable names. Again, space in there. fine, first obs, again, space. And also you find you tend not to create variables starting with a digit. Some systems will allow it, other systems won't allow it. The good alternatives where you run things together, this is called camel case, which is pretty obvious when you've got multiple words and each word starts in a capital letter. There's an alternative that called Hungarian notation, and it works very similar. In fact, it's almost identical, except that before the name is always prefixed with the type of data it is. So if max temperature, which is probably going to be an integer, you'd start int max temp, because then it's dead obvious that this is meant to be an integer value. And if it was a real value, you could call it real underscore. And similarly for things like observation, that might be text string, so you prefix it with str. Okay, so there's there are variations on good alternatives. What you need to do is pick the one that suits you best and stick to it religiously. I mean, really stick to it, otherwise you'll confuse everyone. And the ones to avoid, again, I think most of them, think of it from the computer's point of view, and hopefully a lot of these avoiding ones should be quite self-explanatory. This is just a little section here on using special characters in data. There are some things you can get away with, but in general, avoid them as best as possible. In fact, we had a good example of one yesterday when we were setting data up. I'm just going to quickly try and demonstrate this. I'm going to open Word, an empty Excel spreadsheet. So I'm going to just make it a bit smaller. And in here, I'm going to say writes apostrophe S. Okay. And in my Word document, I'm going to do exactly the same. I'm using exactly the same keyboard keystrokes, sorry. And we'll copy this and paste it there. And if you just make this much bigger, you might be able to see that the apostrophe is actually two different characters. Yeah. So is that the same as that? Well, no, it's not, because this character in position number 6 is different. So again, you have to be very careful if you're copying from one application to another, especially for the non-standard alphabet type characters, whether or not you've created the same, it's copied it the way you thought it was going to copy. You're very careful of that. And that's a problem we actually had yesterday when someone couldn't run a command in R. I suspect it's because he copied it from somewhere and it had copied it this way, and it was R only likes it that way. Okay, so there's another good reason for why, in general, don't use non-alphabetic or numeric values in your data or in the names. Okay. And finally, we get onto the inclusion of the metadata in the data table. I think I might better read inclusion of metadata with the data table, because you don't actually want it in the data table. Metadata is just data which describes the data. So strictly speaking, if we have got a table, you could argue that the column names are metadata. Yeah. But the vast majority of the metadata is really the description of what these columns represent. So species, it's, just looking at this, it's some kind of categorical value, 2 characters, and you'd want an explanation of what each of those were. Yeah. Sex, if you use M and F, that's probably self-explanatory, but again, you would still write it out in the metadata. This field labeled sex can take two values, M or F. Okay, the weight, you would say it has to be, perhaps it has to be expected to be an integer. You might even give it a range of possibilities, you know, zero, it can't be negative, for example, you might say. You may want to put a maximum weight, but you certainly want to say what you, excuse me, what units you're talking about. Okay, and all of that goes into the metadata, which you need to associate with the data table. There's a link here, I think, about the creation of metadata, which is quite good. And the suggestion is at the bottom here, a folder level readme.txt file is a classic way of accounting for all the files and folders in the project. In fact, I would suggest to you that rather than just call it readme.txt, you might want to call it exclamation mark readme.txt, because that way it will ensure that if the folder is sorted, it will always appear at the top file. Yeah. Okay, so I shall slowly, in the next 3 minutes, read the key points, and then it'll be time for coffee. So what have we got? Avoid using multiple tables. Avoid spreading data across multiple tabs. So together, that means one file equals one workbook equals one tab equals one table. Record zeros as zeros. Use an appropriate null value to record missing data. And the chances are, unless you've told the metadata how you're going to do this, leave it blank. Do not use formatting to convey the information or to make the spreadsheet look pretty. Again, the chances are you're just going to be collecting data and you're not interested in being pretty, I don't suppose. But that's probably more of an issue for when you're importing someone else's spreadsheet. You've inherited it, you've stolen it from someone, and it had previously been used as a format of a report. Place comments in a separate column. Why? Because a comment is another piece of information and therefore gets its own column. Units in, you can record units in column headers if you want, but again, it should be referenced in the metadata as well. Only one piece of information in a cell. Avoid spaces, numbers, and special characters in column headers. Just stick to the alphabet. And again, you can use abbreviations, but in the metadata, you can explain, you're going to explain what that column is anyway. So reasonable abbreviations is fine, but make sure you've explained it all. Avoid special characters in your data. That is always the case. You know, basically your data is going to be numbers, floating point numbers, so you can have a decimal point there. If it's currency, don't put the currency value, currency symbol in there. Put that into the column header if you need to. Don't, so the number, it's in the column itself, it is just a number. And don't forget to record this metadata in a separate plain text file. Again, I don't think I mentioned it there, but plain text is quite important. That's why it's readme.txt, not a Word document like that. Because again, text files like CSV are universally recognized. Okay. Okay. This when I said that, you know, if I put the 7th to the 12th, 88 in the UK on my locale, that would be interpreted as the 7th of the 12th. But if that was an American format, it would be the 12th of July. Yeah. And again, if you're putting it in yourself in America, you probably know this. But the real issue is if you're importing data and it just said 7/12/88. If that had been created on an American system and you import it into UK system, it's going to be wrong. Now, that is probably the worst example, because had it been the 13th of July in the UK, 7/13/88, that's fine. But 13/7, I beg your pardon, if it had been American date, 7/13, it would, on your Excel version in the UK, say, oh, that's not a date. There's no 13th month, so that can't be a date. Okay. Now they're going to stand out because what it will look like if you looked at the data, it would have this sort of effect here. This isn't the data, it's a string. And so it's kind of going to stand out. The real problems are the ones like anything less than 12 in the date, where it's the 6/3 is at the 6th of March or the 3rd of June. And again, Excel will just interpret them both as dates. And on one, depending what way it is, there's a good chance of getting it wrong. Okay, so you have to be very, very careful in dates. So what we have are just a little few exercises on things showing how things can be wrong. And then after the exercises, we'll go and look at how we can sort of put them right or make alternative arrangements. Okay, so there's 3 little exercises here. I'm going to leave you to do them all. It's based on the messy data spreadsheet, which we've been using. And it's really just different ways of looking at the dates and perhaps changing the dates and seeing what happens. In this last exercise, what happens when the date tab is exported to a CSV file? I'll just quickly show you, if you haven't seen that, how that is done. So here's my little spreadsheet. If I want to export this to a CSV file in Excel, I can say File, Save As, find somewhere to put it, like Downloads. Downloads is fine for me. I'm going to put in Downloads, and then it's saying, what is the file name? It's got nothing in there because I haven't named this, so I'm going to call it SC1. And then in here, by default, as you'd expect, you can save it as an Excel format. But there's a little drop down here, and you can change this into CSV. I'll take the UTF-8 one. Okay, so save that, and it's going to save it into Downloads, and then you just click Save. Okay, so 3 little exercises. If we have a little go at them, and then we'll come back and look at what we got from. I'll just set the timer to. I think perhaps need a little bit longer than that. 8 minutes. Okay, off we go. Any questions? Either shout up or put it in the chat, please. Can't quite put that away, but you've got your own copies of that. Okay, hopefully you all got some answers for that. We'll quickly go through them. I realised after I'd set that timer of 8 minutes that the first two we'd pretty well already done, because the first one is asking you about the formatting of the dates, how the date is just by looking at the entered date, can you figure out the date format that was used? And I sort of give you the answer to this earlier on when we were looking at the data formatting, or the data formatting, because you can tell by some of the dates that 219 and 518, because 18 and 19 can't be months, they must be the dates. So the first part has got to be the month. So the answer is that it's in the format of month, month, day, day, year, even though the year isn't actually present. If you looked at those in the formula bar, that's the format it would show you. It says probably was in the US version because that's the way they do dates over there. In the second exercise, look at the dates in messy data spreadsheet for plot 3. And it's asking here, what does Excel think the year was? And again, I think someone actually answered that in what was wrong with the messy spreadsheet. It actually said that the year seemed to be wrong. And basically, if you go to plot 3, let me just actually do this. No, let me just load up messy again. Let's see, for plot 3 here. If I, you can see here that the dates, that's in 2018, 2020, summer 2020. I think I've probably got the wrong spreadsheet open. Let me just, this is survey data. This is probably the better one. 2014. Plot 3. If we look at the dates here, 2015, first dates 2015, these are all 2015 dates, which, given that this is labeled field season 2014, is a bit worrying. Okay, but again, looking at the dates, because okay, those ones are spelled out, but because these ones aren't, if these were actually put in 2014, as the label suggests, then you'd expect them by default of being given the year 2014. So what this is suggesting, that the fact that not only has someone not bothered to spell it out, they've actually put the data in late the following year. And Excel has assumed, well, you must be talking about the current year, 2015. Okay, so there is a strong case for making sure you actually spell out the date using the, even if it's just the 2-year format, unless you're going over the century, 2930 boundary. Okay. That's pretty much what it tells you here. It's actually 2015. And then it explains how that happened. Okay, and the final one in the exporting of the data tab. Again, there's lots of, I think most of this is just, as far as I told you, how to export the data set. So if I go, where did I put it? Downloads? Probably downloads. Downloads, messy one CSV, I called it, I think. Now, if I right mouse click on that and I'm going to open it in, I've got something called Notepad++, but Notepad or any text editor will do. And if I look at this, now this is the export of plot 3. And you can see in here that the dates are being exported. Oh, actually, it's in the same one. I'll tell you what, let's do this for real. I've got messy data up here. Oops, messy data. dates. This is what I was supposed to be exporting. So let's go through the motions of exporting this file. Save as, I'm going to call this Messy2. Messy2. I want to save it as a spreadsheet, a CSV format in downloads. I'm going to save that. Usually you get these messages saying, oh, you can only save the active worksheet. That's one of the points we made a lot earlier. Only one tab, preferably. So I've saved that, and now if I go into downloads, Messy2, and now I'm going to open this in a text editor, Notepad, and you can see here that the dates have been effectively faithfully reproduced. So first of the date, and so on and so forth. So it's just going to record what you see. Because remember, it's recording what you see in the cells, not what you're being shown up here, and certainly not the integer value, which it really is stored. Now, apparently, in very early versions of Excel, many years ago, it would actually record the integer value when it was exported. And that has pros and cons associated with it. Now, so having looked at that as a spreadsheet, and I close that, probably did. Here it is here. Okay, if I was to open this as an Excel spreadsheet now, I'm just going to close that and just double click on Messy2 because it'll open it as an Excel spreadsheet by default. And look at these dates. Now, it seems to still have 2015 in there. I'm not quite sure why. That should have come up as 2020 data. Okay. Why is that not doing that?
Did you save that? Did you save that data sheet?
I think I did. I'll give it a different name.
I think try and close it first.
Yeah.
Close the messy data first, and then reopen it. I think it tried to save that tab within your current.
Oops.
I think if you try and open it again, it might.
Let's try this.
I think it's Excel trying to be very.
Right. This is the original one. Oh, hang on. Just. Right, so this has got 2015 dates in it. I'm going to save this as, I'll call this Messy3. And I'm going to save this as a CSV file in downloads. Okay. I'm now going to close that.
So what? Yeah, close that now. Yes, because it saved that current Messy3 as the tab within your workbook.
Just refresh that. Messy3. If I double click that, and now these are all, whoops, the ones which were wrong, 2015 and now 2020. Yes. So because in the CSV file itself, it just says 3/11. When Excel brings that in, it's going to interpret that as this current year because it's the first time it's seen it. Okay. I'll just go back to close these. So again, things to be careful of. So what we're getting, you're probably getting the idea here is that using short data is possibly not a good idea. There's a little note at the bottom of it where I think I mentioned this. Some early versions of Excel, I think you'd have to go back a few years now, so you're not likely to come across it unless you work for Public Health England, I think. It used to put the internal date integer in the file. Now, in most cases, that's probably bad because it'll get interpreted as an integer. But on the other hand, if you then imported those integers and said, treat them as dates, you would get in fact the right date back into Excel. So it's a bit swings and roundabouts, but generally speaking, doing that as an integer is probably bad because it just causes massive confusion. because when you see, even if it's a short date, you know it's meant to be a date. Whereas if it's just an integer, you think it's an integer. The bit on historical dating, I think we've already mentioned, and I've shown you the examples of what happens if you go back to 1899, can't handle it, and it will just treat it as a string. So you have to be just another one of the reasons for being careful. So that brings us on to, well, what are we going to do about all this? What are the preferred date formats? And we sort of already had a clue to this right at the beginning, where we started saying, you for each column, only one item of data. Now, it's fair to say that, well, a date, you pretty much treat that as an item of data. But we've seen we don't actually have to give the day, the month, and the year. We can just do the day, the month, and it'll interpret the year. But if we were to spell it out, year, month, and day, then that is very unambiguous. And it means that if they've all got their own columns, it doesn't matter whether it's international dates or UK dates or whatever, year, month, and date all have the same interpretation. The other advantage of using year, month, and date, and here the order of that is quite important, is that if they were written that way, even if I strung them all together and had 2010, 13 for today's date, you would still be able to, well, you'd be able to recognize it as a date, and you'd be able to treat it as a date in the sense that you could sort it in chronological order. Yeah? If I'll just see if I've got a spreadsheet open. So what I'm saying is that if I have 2020, 10, 13, 2020, 09, 13, 2020, 08, 13. Although they are effectively just numbers, if I was to sort those, because of the way I've got them, I've done the year, the month, and the day. If I sort them, they actually end up in the earliest date is first, and the latest date is last. Yeah. If, on the other hand, I was to take some treat them as strings, and to stop them interpreting as dates, I'm just going to put the little hyphen in there, quote in there, and say 2020/08. I'm going to have to change some of these. 13, like that, and then do the same for the other ones. The problem you would have if you've got a load of dates like this, I'm not going to do them all for the time, they won't sort correctly. Yeah, because the collation will be slightly different. And certainly if I actually did it the right way, if I did, actually if I did it that way, it probably would work. But if I did 13th of August 2020, if I started writing dates like that as strings and treated them as strings, they wouldn't sort in the right order. Okay, so the advantage of having them as a single string is you can collate them properly, and equally that will still work if I had year, month, and day, because that would be 2020. The month would be 10, day 13. If I had I've had 3 columns like that, provided I sort them by year and then within year by month and within month by day, I'm going to get a properly sorted chronological order of the dates. Okay, so there's lots of advantages of splitting them out like this, or at least doing them year, month, and date. So what a little exercise here. What we're going to do is the tab dates in the messy data, which I probably haven't got open again. Let me just open messy data. We've got a tab called dates, and you can see the dates in here. Now, what the exercise wants you to do, let me just close that down, is to look at the dates and split them out into the year, the month, and the year and the day. And Excel and the other spreadsheet programs all have nice little functions called year, month, and date, and it allows you to extract the year part of a date, or the month part of a date, or the day part of a date. So I'll just do perhaps the first one. I'll call this year. And here I'm going to say, equals year. Don't forget the equal sign. Equals year, open brackets, and then A3, close brackets. You probably want to format all of these as numbers with no decimal places. Okay. Just before I do that, if I was to format as a date, you can see what it comes up as. Completely gets it wrong. But if I do it as a number, format cells as a number, no decimal places, you can see 2015. And equally, if we have a month there and do the same thing, we can split them all out. Okay. So your little exercise is to practice doing that. Apply the formulas for each of the row of the table. You sort of drag the formula down if you haven't seen that being done. I'll just demonstrate. So I've got that there. If I drag that down, it copies the formula and changes the cell down here. Okay, so you're just going to do that for the year, the month, and the day. And it does remind you, make sure that the new columns are formatted as a number and not as a date. Okay, that's pretty quick, I think. So we'll just give you a couple of minutes to do that. And let's see if we can all get three nice columns, year, month, and date. Okay, hopefully what you should all have ended up with is something looking a bit like this. The days separated out by the months, January, February, March, and so on and so forth. Okay. Format, don't forget to do the format cells, and you want it a number with no decimal places. Pretty much what you got. Only I did it in the other order. It doesn't really make much of odds, except that year, month, day is the way you're going to get it to collate properly. Okay. The little exercise, which I don't know what we'll do, is it's just doing effectively the same thing, using times as well. And if you want to get the time, you can use the now function. I'll give you the date and the current time. And then you can format in exactly the same way, because there are functions called hours, minutes, and seconds. So that's completely analogous. Another way of storing date is the year in the year, day of year. I'm not quite sure how popular that is. Certainly Microsoft don't think it's very popular, because they don't, although they give you the month and the day functions, there's no day of year function. You've got to build it up yourself using this sort of bit more complex set of functions. Okay, and like that, I'm not quite sure how often day of year is actually used as a format. But certainly you will get storing data as a single string. So here's the example. We started off doing the first part of this, the year, the month, and the day. And then you can add on hours, minutes, seconds, and you can even have milliseconds as well, or microseconds. Milliseconds normally, okay? And the formatting of this, there are various formats spread out like this, or this type of format, which are international standards, and they're recognized by all of the programming languages like Python and R and SQL and what have you. So having them as single strings is perfectly viable and can be quite convenient if you know you're going to process those dates further down the line. Okay, so key points right at the end: extreme caution when working with data. And certainly splitting the data into component values can make them easier to handle and internationally recognized, because again, if we go back up into our day, month, and year, I mean, no one is going to get confused by what they mean. Yeah. Whereas dates like that can be a problem. So moving on, we have quality assurance and control. What do we mean by quality assurance? Well, we want to make sure we don't inadvertently add our own mistakes to the data. I mean, we know data might be imperfect. We've discussed missing data, but basically, you know, we don't want to add to the problems. And one of the best ways of doing that is to, if you're actually inputting data into a spreadsheet, is to have the data validated as you put it in. Okay. And again, Excel and the other spreadsheet programs have ways of doing this. What we can do is we're going to input some data. We've got a semi-clean combined tab. Let me just find that. I've got this up. There you go, semi-cleaned combined tab. And you can see this is really just the slightly cleaned up version of what we had before in the previous tab, in the other tabs. Looking a bit better. It contains message data from tabs 2013, and it's just been cleaned up a bit. Okay, select start a column from the spreadsheet you want to validate. For example, the plot ID. Let's go with that. Plot ID. On the data tab from the top level menu, select data validation, data tools, data validation. So at the bottom down here, because this is going to be my new row going in, I want to go to data, data validation down here, and you get this little dialog box up. And in this dialog box, you've got three little tabs. The most important one is probably the settings, but you can give a little input message. So when someone hovers over, you can get a little message saying, I don't know, give a number, plot number. You've got a little error alert message where you can say, should have been a number. And for the settings, we can say how we are going to control the values put in. So we're interested in whole numbers, I think. Yeah, because these plots have, I think it tells you somewhere between 1 and 24 of the plots. So I can also have lots of options here between, nothing between, so on and so forth. Lots of things like that. And here I'm going to say a minimum of 1, maximum of 24. Okay, so I think that is what the metadata tells me it is. Okay, I'm going to say okay. And so now, if I was putting in new data here and I try to put in plot 34, it's going to come up and tell me, should have been a number, and I can put another message in there if I wanted to. Cancel that, 0. No, that's not good either. So unless I give it a value between 1 and 24, like 13, it's going to object. Okay, so you can use that to check the data that you're putting in. We'll just do, I'll just do an example rather than read the notes. So this calibrated scale seems to be yes or no. Okay, so down here, I'm going to say validate any value. Here I'm going to take it from a list. And I'm going to say, yes, listed item was sort of like commas and no. Okay, I could put the messages in, but I won't bother for time. And now you see here, I've got a little drop down list and I'm limited to picking yes or no. Can't get the wrong value. Well, I could if it was meant to be yes at that point, but you know what I mean. You can't start typing in Y, for example. Yeah. So confusion like that is avoided. Now, this is all well and good, but what we seem to be doing here is I'm setting up a cell with data validation, and then I'm putting a value in. And that is very time consuming. Because if I now go down to my next line down here, I can now put in 56 because there's no data validation on that cell. Okay, and as you think, well, hang on, this is going to defeat the point of the exercise. If you know, I'm not going to keep putting those data validation cells in, surely. So what can we do? I'm just going to delete those ones I've just done. What I'm going to do is I'm going to put the validation field back in here, just as I did before. Oops, wrong one. Any value list, oops, any value whole number between 1 and 24. This one looks like M and F for male and female, so I'm going to do the same sort of thing down here. Here I'm going to use a list, M, F. Okay. And you can see for those two, I've set values. Now, before I continue, what I want to do is make all of my data, I'm hoping this goes up to the top, the whole of my data down to row, including row 90 here, into a table. You do that by just selecting anywhere in your proposed table. You can go to Insert and click on Table. Now, if you look at this, it will try and stop at the end of the actual input data. And I just want to extend that by row, so it covers the data, which includes my formatting, data validation, okay? Everything else is okay. Okay, so you can see, oops, see down here, this last row has been included. And if I go down here, you can see I've got my validation. So here I can put in, I can't put in 34, doesn't like it. I can put in 12, and here I put a drop down of people. Now, assuming this is my table, and I've got values for here. I haven't got any validation on here, but I could have put validation on there, so I'm just making this up. That's 34, and Yes. Okay. Now, if I now use excuse me, the tab key to go on to the next value, it knows to go to the beginning of the row of the table, and it will create that into the table and adds it into the table. And the advantage of that is that down here, oops, oh, that should have extended that as well. That's a blow. Still there. Why hasn't it done that? Okay, perhaps this works best if the way I normally demonstrate this is by having the formatting row right at the top and then extending the table. And then the formatting instructions get carried along into the new lines. Okay, so that's how you would do it in practice, because otherwise there's no point in setting a cell to a value and then having to put the value in. So just back to the note, it just gives you examples of the different types of things you can do. So any value you can have. You can restrict it to a numeric range. As exercise there. Data to entries from a list, again, much as you've just seen me doing. Okay. Okay, so 2 little exercises there for you to do, I think pretty much repeating what I've just done. So feel free to pick different columns if you want to. Okay. One is pick a numeric one and one from a list. Okay, and just the same technique as you've just seen me do. So we'll have a little 3 minutes for that, I think. While I try and work out what I did wrong in that other one. Okay, off you go. You try to do the simple, adding to that messy one, and I'm going to create a brand new spreadsheet to and get it right. Okay, let's just have a little look at that. So allow values between 1 and 24 for the messy tab. So pretty much, I think it's actually the one I actually did. Whole numbers between 1 and 24. And that will restrict it. And again, you can put in the alert message if you want to, using the input message and the error alert message. And input message. For the other one, you can see there what happens, or you've also got options here. So you can either have a message coming up, or you can get to circle the invalid data if you want to. It only applies to newer version of Excel. I think the note actually suggests that you can't do this retrospectively, but now in the later versions, I'm not quite sure when it came in, you can now actually get it to highlight things which are wrong, which had been done previously. You still have to go and fix them again. Restricting the data from a list, again, that is very much as I showed you doing. We're going to select, say it's going to come from a list. They've taken the option to circle the invalid data. And you can see down here, it's circled SH because SH isn't on the list separate by commas. All right. So there's quite a variety of validations that you can do. Just go through them again. Oops. This is my little example I'm going to show you in a minute. So for the data validation, data validation, drop down arrow. So yes, I've got the option to circle invalid data there. Okay. But of course, okay, you can do that historically for data which you've imported and then you're going to check. But for your own data, you'd set the fields, the validation up in advance. So here I've just got, that's the wrong one. Let's say that. This is a little table I've just set up, date, value, and string. And what I've done is for the date, I've put it has to be this year, value between 1 and 100, string has got to be A, B, or C. And you can see now as I extend the row, the column, the length of the table. So the first of the first 21 is going to be invalid, and it stops me. So first to the first 20. Oops. That's a typo error, which again, look how well it stopped me on the typo error. That's the first 20. 78, 34. B. I'm doing these correctly. If I go down to the next one, again, if I do the first of the first 21, it objects it. Because now, if you set up all your formatting in the front row before you put data in it and make the whole thing into a little table, then not only when you get to the end of the row will it go back to the beginning of the next row automatically correct for you, it will, the new row inherits all of the formatting in the cells. Yeah. So once you've set it up once, you can just input to your heart's delight. I'm not quite sure. No, doesn't like that. No, of course it doesn't. I'm just extending this table. Yes, you can see here. The other concern about inputting large tables was that as you get longer, the column or the row, the first row, which has the data, the column names in there, is going to disappear off the top. But in fact, if you create this as a table, then as you get down, further down, you can see the column names are moved to replace the letters at the top. So you can make this as long as it needs to be, and you will never lose the column names. Yeah. Again, that only happens if you've created this as a table. If it wasn't a table, they would just be left as A, B, and C, and you'd have to go and find them. Okay, back to the notes. Identifying outliers. The first few little points here are just repeats of what we've already discussed. One, never mess around with your real data, always take copies. The second point, keep track of your modifications. Back to the README text or the exclamation point README text. Keep a track of what it is that you're doing. Okay. It's useful if you're doing lots of these that you can have a little template to say all the key things in there. So sorting data, sorting data, the advantage of sorting data is that it's going to help us identify any outliers. In most cases, again, if you've used data validation, hopefully there won't be any. But the classic outlier type thing is decimal points in the wrong place, something like that. Okay, and this is going to help you to identify them. So what we're going to do is sort some data, and then see if anything percolates to the top or percolates to the bottom. So what we're going to do is look at a semi-cleaned tab, which is that one. The semi-cleaned. Yes, let me just get rid of my 2 lines there. Just clear that out. It contains data from the rest of 34. We know that. It's not yet fully cleaned. So if you look at the weight grams column, and sort it largest to smallest, what do you notice? Okay, so that's a little exercise. That's only good. In fact, I think I'll probably do that online as I've got this open. So the weight grams column, if I click on this, again, if it's a table, I get the drop downs in here. So I'd say smallest to largest. And we go down to the bottom there. Oh, look, I've got a whole host with grams written in there. So I've already discussed why that's a problem. And we've got some missing data here. If I sort them the other way around, they probably have come to the top. Yeah. So you can see here, all of the grams are coming at the top. So we can use that to identify potential problems. Okay. I've got another little example I wanted to. I've got another little file here called repcand, meant to mean Republican candidate. So we're talking about the American election here. And I think I've got about 3,000 entries in here. And the idea is that Trump and Pence, this is just random data, okay? Now on the face of it, I could sort that one way or the other, but because these are string values, that's not necessarily going to be helpful. But one thing I can do, something that we said we don't generally do in spreadsheets, is I could actually go to the Insert tab and say Insert Recommended Chart, which is offering me a bar chart, histogram chart. And you can see immediately from doing that although the vast majority of them are Trump and Pence, I've got a Biden in there as well. Now, with 3,000 or 30,000 rows, I'm not going to spot that by eyeballing the data. So it's useful to have little tools like this. And this is probably an example where you could use Excel to do a bit of the EDA. We'll be doing this sort of thing again this afternoon in Open Refine, but you can do quick little tests like this just to check that nothing's crept in. Of course, the real way of preventing this Biden creeping in, there's only one of them, I think. It would be to have the data validated on strings of Pence and Trump, and then you would never get the problem. But had that been imported, then you'd have to go. You'd have the option of getting it circled, but again, if you've got 30,000 of them, how are you going to spot that? So there are some advantages of using very simple techniques like this to put it in. The other thing you can do on the same basis is to actually create a pivot table of the same data. And this is now telling me, oh, there's only one of Biden. And if I double click on that, it will actually show me what line it was on. Okay, so there's little things in Excel which you can use effectively to help you clean your data. But the vast majority of it is really just for data collection as much as anything. Yes,
there is a quick question in the chat from Miriam. I don't know, can you see that, Peter?
I can't see the chat at the moment.
So what is the difference between the table function and the data filter function?
The table function? You mean creating a table as opposed to, well, okay, let me go back to one Rabbit table. Right, this is currently a table. One of the options you have in a table, if you go to table design, you can say convert it back to a range. Okay, so now it's just going to be, it doesn't lose the coloring, but now it's just a range of numbers. So again, if I scroll down, I lose the column headings at the top. Yeah. If I take this, if I just click anywhere in this thing I'm going to create into a table and say create table, it will make a guess on what I think the length of the width and length of the table is, and it'll guess that I've got table headers, which is correct. So I'm going to say OK. And as soon as I do this, then when I scroll, the column headers replace the letters at the top in a nice little green there. But also each of the columns themselves are automatically given the drop down, which allows me to sort and filter and various things. Okay. Now, all of the functionality of this is actually available without using a table. It's just more convenient to use when you have got tables. Yes. And there's lots of other little things that you can do with tables which are more convenient. Certainly the example I've just used of when I had the formatting in there, wrapping it round to, you see, when I get to there, it will automatically, oops, if there's a table, it would automatically go to the beginning of the next row. And that new row would become part of the table. And there are some operations where it's convenient to refer to the table by a table name than anything else. So there's lots of little hidden advantages of using tables. But in terms of the filtering, if this was on the table, if I take it back and move the table back to a range, for any one of these given fields, like species ID, I can still select that and go to data and say I want to sort it and things like that and filter it in various ways. Yeah. So most of the things the table gives you are normally available in other places, or some of them are, but it does have the advantage that it becomes an object in its own right, which will automatically extend itself when you go down. So this not being a table now, oops, now this was part of the table. So now if I get to the end there and I hit tab, it just goes to the next cell. Yeah. Whereas for data input, what I really wanted to do is come back and start a new row. And it will only do that if it's a table. Does that answer the question?
Yeah, thank you. I was just, so it combines several Excel functions in one.
Yes, it's several functions and plus a bit extra as well, which you can't get any other way, like what I've just shown.
Okay.
Conditional, we have done that. Conditional formatting. Well, again, we're getting to the point where we're kind of breaking our own rules by using conditional formatting. It's good to look at, but the point about conditional formatting is that it doesn't get exported. So if we look at the semi-cleaned one, 2 color scale formatting to the weight grams. If we just have a look at what it says. This is the conditional formatting. You can create lots of very complex rules doing this, and you can make very pretty looking things. And the idea is that you get this sort of effect, yeah, showing, color coded, typically from green to red for low to high values or something like that. But the point about it is that if you export this as a CSV file, you're losing all that information. So if you imagine this is like a traffic light system, and again, this is obviously a graded color code, but you can actually have it set up, change this to say, I want red, amber, green type thing. And then you could do it like that. Whereas the reality is, if you wanted that as information, you're better off having a column called RGB and then assigning it to each one into RG or B. Yeah, because that will get exported, whereas the little colors here won't. Okay, scanning for outliers. Nice to be able to do scans for outliers in spreadsheets. Now, we did a brief one with the doing the weights and the grams. Yes, in our case, it showed up the fact that we've got these ones with G's in there, which probably shouldn't be there. But equally, had one have a decimal point in it, and we sorted lowest to highest, then that would stand out as well, equally well. And the other example I did with those Republican candidates one, that allows you find outliers there by drawing very simple little graphs. But most of all of that sort of stuff we're going to be able to do again this afternoon using OpenRefine. And again, all of the other tools are Python, SQL. They all have ways of helping you find outliers. So the real key point about this, apart from always keep a copy of the original, use data validation to prevent accidentally entering invalid data. Because again, unless it's an automated system, you've got to copy the data and type it in. Your fingers are prone to errors. Yeah, and that's, I mean, the data itself may be wrong, but you don't want to compound it by putting decimal points in the wrong place or putting the wrong year in and that sort of thing. So sorting to check for invalid data and other little techniques as well. Again, use conditional data cautiously. It does say cautiously to check for invalid data. I would suggest that that's only really useful if you've got a limited amount of data and you can sort of eyeball it. Now, I think you can actually on the color coding, you can actually sort by it as well. So that could be useful. Okay, and then the final little chapter is how do we export our data? Well, I've kind of already told you the story here. Always export CSV files because every man in the world and his dog knows how to read a CSV file. Okay, a little bit here about the various Excel formats. The old one, so this is pre-2007, limited to 65,000 rows. We get the new one, XLSX, which can now take 1 million rows, and is in fact just a dressed up zipped file, in fact, or zipped files, zipped folder. And there are little variations on that if you've got macros and stuff like that in it, but it's not really that important. The problem with this is that eventually Microsoft are likely to retire XLS and no longer support it. And at some point, XLSX will be unsupported, whereas CSV file, in a sense, doesn't need any support because it's just such an open standard that everyone knows. You can get tools which pretty CSV files up, but generally speaking, it's just text with separators separating the values. Another important point to all you researchers out there, journals and grant agencies are increasingly requiring you to deposit your data in a data repository. And if you do that, they will quite likely expect you to provide them in a format that other people are going to be able to read. So proprietary formats like Excel are probably or quite possibly not going to be allowed. So you have to provide the data in CSV format. It's moving on a little bit. There are little variations on CSV. CSV, comma separated values. It's the clues in the name, comma separated values. But in reality, there are variations on this, because certainly a CSV file in a lot of Europe would actually use semicolon to separate the values. And related to well, essentially what you need is some kind of single character to separate them, and some of them will use the tab character, and hence then it becomes a TSV, tab separated values. But essentially it's the same technique. You've got the values separated by some kind of known separator. The advantage of being able to swap between it, well, use the one of your choice if you like, is situations where your data may contain one of the delimiters. So if you've got a CSV file, comma separated values, and your data contains strings which have commas in it, then you have two ways of dealing with that. One is you can change your delimiter to something else like tab or semicolon, or you could ensure that the strings which have commas in them are in some way delimited in their own sets, in their own right. And typically that's done using quotes, double quotes or single quotes. Or alternatively, you can actually escape the delimiter character itself. So how does this all work in practice? How do we save in Excel CSV? Well, we've already done this once. So file, save as, and then select the one you want. And you can see Excel has lots of different formats you can save in. You can see here, this is taken from a Mac and it's saying comma separated values. You'll probably find there are different CSV type variations which you can have. And the one you should pick, it's the one which isn't, oh yes, it is right up the top here, common formats, CSV UTF-8, comma delimited values. Okay, by default, again, nowadays, most files which reads, most applications which read CSV files will happily deal with a UTF-8 file. I'm not going into detail of what UTF-8 is, but basically it's a pretty safe bet. Okay, because everyone can read them. This little message here cannot be saved because it contains multiple sheets. That harks back right to the beginning. We said only put one tab in a workbook. And by default, what it will do, it'll save whatever tab you currently have selected. Note and backward compatibility. You can open CSV files back in Excel. Well, in fact, on a Windows machine, if you've got Excel installed, it will assume that you want to import or open a CSV file as an Excel, as is denoted by all my CSV files down here. They've all got the little Excel icon in there, telling me it's going to open it with Excel by default. And if I want to change that, I've got to deliberately go out of my way to do so. The note, when data contains commas, I think I've already mentioned, if it's a CSV file and it's got commas, what will happen is it will automatically be the actual whole field or value will be quoted, put in quotes. Again, that's a perfectly standard way of doing it. Most applications will deal with that quite happily. If you're exporting, it will put the quotes on. If it's importing, it will strip the quotes off. Yeah. So generally speaking, something that you perhaps want to be aware of, but in general doesn't cause the problem that it used to a few years ago. Okay, and finally, the key points. Common spreadsheet formats will often not be read correctly into data analysis. So keep it simple, CSV. Exporting data into formats like TSV and CSV puts it in a format that can be used consistently by most programs. Okay, any questions? Because if not, that ends what we are going to talk about for spreadsheets. This afternoon we're going to do Open Refine. Some of the things that we've looked at here we'll see again in a slightly different format. Here we've been talking mainly about the data organization, and the key takeaway is one table per spreadsheet file, rows and columns. Rows have the types or what it is you're recording. The rows are observations and the values are in the cells. If you stick with that, you can't go far wrong. Add a bit of data validation at the outset, because let's face it, you're supposed to know, I'm sure you're supposed to know at the outset what type of data you're trying to collect. You know, whether it's a string or an integer is pretty obvious, but if that integer has a range, that's useful to know. If that string is actually a categorical value of limited options, then again, you can put that to data validation. And that's going to save you an awful lot of work later on during the checks and what have you. Okay, any questions? If not, I think it's lunchtime.